So I'm going to talk to you about hijacking build pipelines. I'm Kyle, and this is Greg, and we both came from Rackspace. All right, so when I talk about build pipelines, I'm talking about your source control. So that'll be from GitHub, GitLab, Bitbucket, wherever you're storing your code, wherever devs are storing their code, depending on what side you're on. Your continuous integration, so running your tests. Are you running it on Jenkins? Are you running it on Travis? Do you just run it on your local box? Oh, what actually it is? Where are your tests running? As well as upstream sources. Talking NPM, PyPI, Ruby gems, all of those. The reason that I care about this is that I work with a lot of open source software where we'll set up builds for that software, and anybody can contribute, anybody can push patches in, and so what sort of threat vector is that? Like, what can you do with that? What could be leaked? And so kind of the precursor here is that all real sites need secrets. I mean, you might need secrets for testing if you're deploying to production. You might need database credentials. You might need OAuth creds. It might be your cloud credentials, GitHub tokens, Twitter tokens, the actual SSH keys to get onto boxes. So you need to manage these secrets in some way. Not everybody does this appropriately, and credentials get leaked. Like if you do a simple search on GitHub for AKI-AJ, you'll find Amazon credentials instantly. Right? So I'm showing 1,071 results for just finding for that string. Right? So run infrastructure, do whatever, keep going. I think this is a problem with how people treat Git. Like you start up a new project, you run git add, everything goes in there. If you had any secrets encoded into the repository itself, it's there for the world to see the next time you git push. This even happens to people that know what they're doing. Rich Mogul gives a talk at Black Hat on working with the cloud and to do security appropriately, to set up your development environment appropriately, as well as lock down your instances and how you handle your keys. When he ended up looking at the account that got hijacked for him, what did he find running there? Right, so they didn't actually care about his running infrastructure at all. They just wanted some place to go mine for cryptocurrencies. So in this case, they pulled up really big instances and just started spending his money. If you want to read more about that, you can go to bit.ly/mogul. He does a good write-up on what happened, what he ended up doing forensically to figure out like what they had done, how far they had gone, and then tried to go back through CloudTrail to figure out what they had access to and what else they tried to get access to. And it's not just in your GitHub credentials either. This isn't an Android file, sorry, the APK. If you look right here in the middle, there's their creds. Right, so every client that downloaded the app has access to their Amazon. All right, so what other fun can we do with cloud credentials? Right, I can spin up new servers. I can take down their servers. I can redistribute DNS and load balancers. Maybe you have another node that you want to put into the mix. I can remount volumes. If you're on Amazon, right, you've got your cloud server and it has a EBS volume on it. You disconnect that, connect it to a separate, like you've got their server and their EBS volume, connect it to your own, add your SSH key, connect their volume back in. Now you have SSH access on their box. For OpenStack Nova, you can append your own key to the main key that they use when they spin up new servers, so that every time the authorized key file gets dropped, you get access to the new servers. So how do we find these keys to begin with? Like I was saying before, for Amazon, you just search AKI-AJ, you find a list of keys, there it is. For OpenStack and the OpenStack providers, it's a little harder because they actually just use a hexadecimal key. So you end up having to look for what would it look like within the code itself. So in this case, OS password is what you'd see if they had it as an environment variable, if they end up setting it there, or if they have it in some config file. Right, so the results are really big here, but it could have come from a library. Same thing with Rackspace API key. We're looking at 3,000 results. And then API key, 305,000 results. But again, that could be the libraries too. It doesn't necessarily mean it's the actual API key. We have to do some amount of triage on top of that. And at least for GitHub, they only let you search for 1,000. You only get 1,000 results back. So you have to break it up. So let's say that we took the Rackspace API key and we were looking for language Python. Right? We can do it with the language and without the language. GitHub has their own search setup for doing this, so you can break out as many things as you want, as well as looking down particular paths and languages. So for this one, we get 420 for Python, and we get 8,303 for the rest. So when I was breaking these out, I ended up having to go through pretty much all the languages and break them into their own discrete bins. Right? Keep splitting. So couldn't we just let people know when they fuck up? Like, those are all there. Their emails are attached in GitHub. So we created a project called GitSecNanny. It searches repositories for those same security oops. Email the original committer and the owner of the project. I'll let them know how to revoke keys, and then also how to panic, because the responses were varied for this. You know, people were like, wow, thank you. How did you find these? Oh, you're such a savior. And this is only a testing project. Testing. Is it your testing credit card? So far, I've found about 265 keys. I'm clearly going after one provider that I want to protect. There are certainly more out there to find. One of the biggest offenders for this were Rails developers. If you look in config initializer secret token.rb, it's got, usually you'll find your OAuth creds, there's actual keys for Rails itself. And this one's kind of infamous. There's a pull request out there that's never going to get accepted that just adds it to the git ignore so that it doesn't happen to people in the future. And the comment from Rails was, they're not going to do it in there because people shouldn't be doing it that way. Yeah. Right, so they're supposed to use environment variables. Like, that's the way you're supposed to develop an app. That's how you're supposed to deploy it. Anyway. So we have to do it the right way if we're doing a security checker. This isn't my security checker. I just noticed this like last week. So Danny Greenfield here, he got a message back. You can't read that. Enhance. There we go. All right. So they said they've confirmed this possibility by manual inspection, and then there's the secret. I don't think they inspected that. Right, so that's it for secrets. But what if you actually need secrets for testing? I mean, it's not like you can live in a vacuum where your code never touches anything. You're not going to build you're not going to build any real web infrastructure with that. One option is Travis CI, and I'll get into why in a second. First, so Travis CI is great for open source. It's free for public repos. You pay for private. You just do a git push. It hits a webhook, and then it'll send out tasks to go run your build and let you know whether or not you had success. It has a lot less control than Jenkins, but it's super simple. Like this is the definition for a Travis YAML. You set up your language. You know, here we're doing Python. We do 2.7. We have some, before the install, we have some steps, as well as the installation, and then what script to run. They have this neat thing called encrypted secrets, though. Like, you put the secret on the web, out in the open. So I was curious if I could use this. And so all this does is it sets up an environment variable that can be used later. So could we leak those decrypted secrets? Like, where do they come out? How do I get the secrets out? All right, so let's say that we open a pull request, and we're going to go ahead and try to echo out their environment variable has the secret. Oh, nothing. What? All right, so Travis, the keys used for encryption and decryption are tied to the repository. If you fork a project and add it to Travis, it will have a different pair of keys than the original. All right, so what that's saying is, if you make a repo, it gets one key. Somebody forks your repo, they get a totally separate key. right? So they could run their own secret stuff that they're running off of their own fork, so that they can do testing. But then only the stuff that's on master will get tested with the original keys. Nice. So let's say we merge that pull request. The secret message then comes in. Just drink. Right, so your only barrier here is code review. And the fact that you have to trust Travis. I mean, at some point, Travis is decrypting your secrets, and they have the keys, so you have no idea. But those guys drink good coffee and live in Berlin, so I assume they're great. All right, so now we'll talk about Jenkins, and I'll pass over to Greg.
Thanks, Kyle. So for those of y'all who aren't familiar with Jenkins or you're not DevOps gurus, Jenkins is a continuous integration and deployment suite used for not only functional testing, but also deployments to production. So even if you're not a Jenkins user, if this is something you've never heard of before, why do we care about Jenkins? Well, Jenkins is the road to production. If there is a Jenkins server, at the end of that pipeline is either a repository that multiple servers are using, or a production server with data we're stealing. So the normal interaction with Jenkins is hipster developer pushes some code to GitHub, and Jenkins is notified via webhook that there is some code ready for testing. What we want to do is masquerade as hipster developer so we can push code to production servers or repositories and compromise them. So let's say that hipster developer makes an oops. He either commits his cloud credentials, which have an OAuth token in them, or he commits his GitHub token directly to his code repository. We're kind of off to the races, right? So if there is a repository at the end of that pipeline, all we do is we propagate vulnerable code that we can scan for, and then pop every single server. Yeah, and the mic. And so you can pop every single server that's using that repository.
Stand back a little further. You can talk from a distance.
Can y'all hear this?
Yeah.
No shit. Okay. So what's the other option, right? The other option is instead of a repository, there's a server with information that we want to steal and sell. So one thing you can do is propagate things for persistence, like think reverse shells or things of that nature. The other option is to try and extract the secrets that Jenkins has out of the build. So there's two different ways to manage environment variables in Jenkins. Either you throw them directly in the configuration, or you're using the credentials plugin, but at runtime, they all boil down to actual environment variables. So both plugins could possibly be leaked if you could sneak something like this into the code. So the goal of this script is to print the environment variables and then phone them home to a server. And no problem. So that's kind of cool, but that'll only give you one server. You know what's really cool is compromising multiple servers. So how do we do that? We target the Jenkins install directly. So for my testing, I was using the Jenkins database library, or Jenkins user management for authentication. Jenkins is like widely configurable, so you might not run into this unless you use that exact authorization to replicate this. But so I was curious about how Jenkins actually decided to manage its users, and it boils down to this file called config.xml. And here's what it looks like. You'll see that there's a username, a hashed API token, and a hash password. So what caught my attention is they're using JBCrypt. And so I did some more digging, a lot more digging. all the way down to this file called Hudson Private Security Realm. And what you'll see is how Jenkins is actually encoding and storing passwords. Now, there's nothing really wrong with this, except that it's really easy to duplicate. So using this 3-line Java code, we can create hashes that are passable to Jenkins. But so now we have to figure out a way of how to actually pass those hashes and get them installed on Jenkins. So what if we had something like this in our build? The goal of this code is to locate the config files for all users and attempt to replace all hashes to a password of our choice. Let's find out. So over here is my Jenkins server. And to show that I'm not cheating, I need a password. Anyone? Admin? That'd be a good guess. So admin clearly doesn't work, right? But so what I do is I go over to my Java code. And we get back a bcrypt hash. So then we go over to the compromised repository. And we throw this in our code. Is that right? Cool. That shouldn't happen. And so if we go back to the Jenkins instance, we'll see that our project is now building, or it's queued to build. And it's building, building.
Oh, Jetty's restarting.
So part of the reason that it's going through this right now is in the script is a command to restart because you have to refresh the file. And boom. We can then... So from there, it's really simple, right? All you have to do is go and change the deploy scripts and propagate them through. The other thing that I wrote, just so, oh yeah, thankfully it worked too. I'm always scared of live demos. The other thing that our script did is phoned home all the users that Jenkins has. So I wouldn't even have to know username admin. I mean, it's right there for me to take. Oops. Yes, maybe. Not in this room. They kick you out. But so there is a catch to this technique in that this config file is only stored on the master node of Jenkins. So if builds are allowed to run concurrently, that's really good news for us. All you have to do is add a sleep function to your malicious code to put the nodes to sleep, and boom, back on master. If you're not allowed to run concurrent builds, you're going to have to get creative. One of the options is to just keep committing. That's because we know that these people that we've compromised are developers, and they're going to be executing other builds. The other thing that you can try is, with the compromised credentials, commit other repositories and push other repositories to try and trigger other builds on Jenkins. But what if there aren't any oopses, right? What if we really want to compromise this deployment system because at the end of it is 100,000 servers that the repository or 100,000 servers that are consuming the repository. Or maybe you have like a vendetta against someone and you just really want to get into their production boxes. Well, one thing that can help you out, or the low-hanging fruit in this scenario, is that they're doing automatic pull request building, which basically means they're taking all the pull requests they get and they're building them before they decide to push them to master or merge them into the repository. Now, from a security perspective, that sounds pretty stupid, right? Like, why would you ever run code that you have no idea what it does? Well, the nice thing about Jenkins is if you were to do this, it would tell us first if it was functional, and two, how the performance compared to previous versions of the code. So there's definitely an argument to be made for doing this. I mean, I'm glad I don't develop because I would probably do this. The other options, though, is that you hit the gate. And you get this notification from Jenkins asking for one of the admins to verify the patch. So if you're not going to give up, and no one likes to give up, you essentially have two options. You have to try to be sneaky or thwart the gate. So being sneaky is nothing really new. You either have to, A, obfuscate your vulnerability, or two, make it so small that it goes by unnoticed. And it can be as simple as yank paste for the Vim camp. This is the iOS SSL verified signed server key, and you'll notice there's an extra goto fail that causes it to fail. So thwarting the gate. Unless our users have reconfigured the webhook that we originally talked about, so the entire process, right, Jenkins is notified that there's code to test via a webhook from GitHub. It's always, or it's by default configured to be at GitHub-webhook on the Jenkins server. And how the process is kicked off is a simple post request. So if you can forge that post request, you can beat the gate and cause a trigger and compromise the Jenkins server and all things attached to it. The worst case scenario, right, is let's say that there is no continuous integration, there is no deployment systems, it's just a repository that you want to compromise. Sneak in your code, hope no one sees it, and it might propagate. So real quick, I'm going to do the quickest overview ever on how to secure your Jenkins server. Bonus round. So disable anonymous access, take code review seriously, gate your deploys, use a random port for slave communications, disable executors on master, change your webhook from the default URL, and it's that easy.
So we can take questions. If anyone has questions, come up to the mic.
This is kind of tall. I noticed that Jenkins failed. I don't really have a question, I have a suggestion. There's a URL you can hit on the Jenkins master that will make it reload all the files without restarting. So nobody will tell. Nobody will be able to tell that you just did that.
Well, so you have to be authorized for that.
Hey, that's my question. You back off. No, so yeah, you're absolutely right. There is a reload URL in the Jenkins server, but there's two problems with that. A, you have to be authorized, and B, you have to know where the Jenkins server is. So this is actually like a blind injection, right? Like I don't even have to know where the Jenkins server is because it'll phone home that information to me.
Okay, thanks.
Anyone else? Anyone? No, I know you. I'm not taking your questions. Thank you all so much for coming. Feel free to come up and talk to us.